We now discuss the solution of a problem from the section three-dimensional geometry, and the problem is on the concepts of the plane. This question has appeared in joint entrance examination main held on 27th July 2021 in the shift 1. The problem is, let a plane P passes through the point 3, 7, minus 7 and contain the line x minus 2 by minus 3 is equal to y minus 3 by 2 is equal to z plus 2 by 1. If the distance of the plane P from the origin is d, then d square is equal to. So we have a plane P that is passing through this point 3, 7, minus 7, and that plane P contains this line. And if d is the distance of the plane from the origin, we have to find d square. We now discuss the solution of the problem in detail. We are given a plane P that is passing through the point 3, 7, minus 7. Look at the illustration. So that is the point 3, 7, minus 7, and that is the plane P that is passing through this point. Now, the equation of the plane P is a times x minus 3 plus b times y minus 7 plus c times z plus 7 is equal to 0. Let us call this equation as 1, where a, b and c are the direction ratios of the normal to this plane. So, the direction ratios of the normal to this plane P are A, B, C. Look at the demonstration. That's the normal to the plane, and the direction ratios are A, B, C. And we are given the plane P contains the line L, let us say, and that is x minus 2 by minus 3 is equal to y minus 3 by 2 is equal to z plus 2 by 1. And what is this? What is this? This is the equation of a line in the plane. And this line passes through 2, 3, minus 2 and has the direction ratios minus 3 to 1. And look at the demonstration, and that is the line L, which is in the plane P, and whose equation is x minus 2 by minus 3 is equal to y minus 3 by 2 is equal to z plus 2 by 1. This line L passes through the point 2, 3, minus 2, and it has the direction ratios minus 3 to 1. So, the direction ratios of this line L are minus 3, 2, 1. We continue in the next slide. So, that's what we have. This is what we have. Now, you see from the figure, this is the normal to the plane and this is the line in the plane. So therefore, they are perpendicular to each other. Therefore, the direction ratios of the normal A, B, C and the line L minus 3 to 1, when they are perpendicular, the direction ratios are to be multiplied. That is minus 3 times A, 2 times B plus 1 times c. So let's recall. So the normal to the plane P, this one, and the line L are perpendicular. Then what happens? If you have two lines whose direction ratios are L1, M1, N1 and L2, M2, N2, and they are perpendicular if and only if L1, L2 plus M1, M2 plus N1, N2 is equal to 0. So we have the normal to the plane, that is the line, the direction ratios are A, B, C, that is L1, M1, N1, and the direction ratios of the line L are -3 to 1, they are L2, M2, N2, and they are perpendicular. Therefore, L1, L2 plus M1, M2 plus N1, N2 is equal to 0. So that will be -3 into A plus 2 into B plus 1 into C. That will imply -3A plus 2B plus C is equal to 0. Let's call this as the equation 2. Now, note that this line L is passing through the point 2, 3, -2. And this line L is on the plane. And it is passing through this point. That means this point lies on this plane. Therefore, this point must satisfy the equation 1. So, in the equation 1, put x is equal to 2, y is equal to 3 and z is equal to -2. Thus we get -a -4b plus 5c is equal to 0. Let's call this equation as 3. Now you take 2 and 3 and solve for a, b, c. So if you get the values of a, b, c, then we get the equation of the required plane, and then we can talk about its distance from the origin. Right. So how to solve? So 2 and 3. Solving 2 and 3, we get A is equal to B is equal to C. We have given you some hints here, and it says you take the second equation and take the third equation, multiply by -3. You multiply by -3. So write down and add these two things. Add these two things. You will get 14b minus 14c is equal to 0. 14 is common. This will imply b is equal to c. Now you put b is equal to c in the equation 2. You will get -3a plus 2c plus c, and that will be -3a plus 3c. That is a is equal to c. Thus you got a is equal to b is equal to c. Thus we got these things. We continue in the next slide. Now we have the equation of the plane, that's the equation 1, and we have we got a is equal to b is equal to c. Now take a is equal to b is equal to c is equal to 1 in this equation. Then the equation of the plane P becomes x minus 3 plus y minus 7 plus z plus 7. Simplifying, we will get x plus y plus z minus 3 is equal to 0. This is the equation of the plane. -3 minus 7. -7 plus 7 cancels. So you get -3. It's okay. This is the equation of the plane. So what is that we want? D is the distance of the plane P from the origin 0, 0, 0. Then we want what is the value of d square. So what is the formula we have? The distance of the plane P, whose equation is ax plus by plus cz plus d is equal to 0, from a point x1, y1, z1 is modulus of ax1 plus by1 plus cz1 plus d by under the square root of a square plus b square plus c square. This is the formula. So here the equation of the plane is x plus y plus z minus 3 is equal to 0, and the point is the 0 comma 0 comma 0. So that will be equal to modulus of 0 plus 0 plus 0 minus 3 by under the square root of the coefficient of x 1 square plus 1 square plus 1 square. And the numerator is 3, the denominator is root 3, and cancelling we will get square root of 3. So thus we got to d is equal to root 3. Therefore, d square is equal to 3. That's our answer, what is required in the question. So the answer is 3. That is the discussion of the solution of the problem from the section 3-dimensional geometry, and the problem is based on the concepts of the plane. I am sure that you have understood the solution of this problem and concentrate on 3-dimensional geometry, and I think you will be getting 2 or 3 questions from that. So go on working out problems from 3D. I wish you all the best. Thank you.